Hello? Are you in there? Are you awake? Are you ready for some algebra? It's that time again. We are ready to get busy and get some algebra going today. So we are going to continue with completing the square. Moving on, this will be the rest of our semester. We'll be right here online 3 times a week, twice a week. Fridays, remember, Friday's a tutoring day. I was online like 5 hours last Friday, just sitting in the chat room, helping anyone who wanted to come along. And speaking of that, if you're struggling with any of this, Mrs. Smith and I both have different chat rooms. We're online every weekday. Most of the time, we're sitting there by ourselves because there aren't a whole lot of students coming on and seeking help, even though when I look at these assignments, I see a lot of you struggling to get the correct answer. So hop online. Come visit with us. Say, hey, I did this problem, even if it was a day before. I was working on this yesterday, and number 6, I just couldn't understand. Let's go through it. Remember, these assignments are set up for you to be able to redo them. So if you go through an assignment and you really struggle and you don't score very many points, come chat with us. Get some help, and then you can go back and redo that assignment and raise your grade. And I do want to mention, if you are going back and doing old assignments online, I look at the assignments I'm posting today, and I'll look at it in the next day or two and make sure it's giving you credit, because a lot of time you have a right answer and it doesn't recognize it. If you're doing ones from last week or earlier, be sure to send me an email or something that you redid that, because I'm not always going back and looking weeks previous to see if your score should be raised, and it doesn't notify me. So if you've gone back and redone an assignment and I need to give you more points now, just let me know. Drop me a note. Hey, Mr. Brock, I did the April 1st assignment over again. All right, I'll go take a look at it and make sure to update the grade book so you're getting credit for that. So, come visit us online and make sure you're watching these videos. We're gonna go through that today. Let me change and get to our lesson here. Get to our ladybug. All right, let's pull this up. We are on lesson 13, completing the square, part 2, right here, and we're gonna work with that. So, math talk, equations with fractions. Fractions are friends. Don't be afraid of fractions. So, solve each equation. X plus x would equal 1/4. Well, when we add fractions, what would equal 1/4? Well, if we had 1... Remember, with fractions, when you add, the base has to be the same, and you add the top number, right? And we want it to equal 1/4. So, it can't be 4 as a base, because 1/4 plus 1/4 would be 2/4, and that's not 1/4. That's the same as 1/2. So what would be another base where 2 of them, the same as 2 on top, would be the same as 1/4? Well, if we double that, 1 times 2, let's double this. So 2/8 is the same as 1/4. So 1/8 plus 1/8, that would equal 1/4. All right, so remember, when we're adding fractions, we have to have the same denominator. And so that would actually equal, let's put it this way, 2/8, which equals 1/4. Right, so 1/8 plus 1/8 would be 2/8, and 2/8 simplifies down to be 1/4, same fraction. So this 3/2 squared. So that's 3/2 times 3/2. Now multiplying, remember to multiply fractions. We've talked about that in the last lesson or two. You multiply straight across. 3 times 3 is 9. 2 times 2 is 4. So x equals 9/4. All right. 3/5 plus something equals 9/5. Remember, adding, we would have the same denominator, and we want it to end up with 9/5. So if we start with 3/5, how many fifths do we have to get 9 of them? Well, 9 minus 3 is 6. 3/5 plus 6/5 equals 9/5. So 3 plus 6. What about this one? These don't have the same base. 1/12 plus something equals 1/4. Well, we know adding, we're going to need it to be 1/12 plus some number of 12s, and it should be equivalent to 1/4. Well, how many 12ths are equal to 1/4? Well, this is, if we took that times 3 to get 12, and we can multiply this by 3, because 3/3 is the same as multiplying by 1. So if we multiply that by 3, multiply that by 3. So 3/12 is the same thing as 1/4. So we want this to equal 3/12. So 1/12 plus 2/12. So 1 plus 2 is 3/12, which is 1/4. Okay, well, fraction review. We always use a lot of fractions in math, and especially going forward. And I know these ACT Aspire and other testing that you do, standard testing, uses fractions. So we don't need to be afraid of fractions. Just understand the rules and refresh our mind on those. All right, let's get to completing the square. Solve these equations by completing the square. X minus 3 times x plus 1 equals 5. Ooh, that didn't even look close to like stuff we've been completing the square with. Wow, that's because this is part 2. We've got another step. We've got to distribute that. Let's multiply those together, right? So x, let's take the x and distribute it into the second parentheses. X times x, x squared, x times 1, 1x. Now let's distribute the negative 3. Negative 3 times x is negative 3x. And negative 3 times 1 is negative 3. And it all equals 5. All right? So we got x squared plus 1x minus 3x minus 3. So let's combine like terms. X squared, 1x minus 3x is minus 2x minus 3 equals 5. Okay, so completing the square would be taking the 2x. And let's make this a perfect square trinomial. Trinomial will be 3 terms, right? X squared and x and a number. So, negative 2, we cut that in half. Remember, that's how we complete the square. We take this and we take half of it. So, negative 1. And then to get that last number, we take that negative 1 multiplied by itself, which would be positive 1. So, it's not negative 3. So, let's move this 3 to the other side first, all right? Plus 3. So, we're adding 3 on both sides. So first, this equation is x squared minus 2x equals 8. Notice that 3 disappeared there. It became 8 on the other side. Not a very good 8 there. Let's make that more round. Equals 8. So what number did we decide that was? Cut that in half. Be negative 1 squared plus 1. It means we also have to add that to the other side. Plus 1 plus 1. So now this is a perfect square, right? It'd be x minus 1 squared, because we figured out it was minus 1 when we looked at that minus 2x term. So x minus 1 squared equals 9. Or this is the same as 3 squared, right? I mean, it's the same thing. 9 is 3 squared. So to solve this, we say, well, if x minus 1 squared equals 3 squared, that means x minus 1 has to equal 3. It could also be, what? Negative 3 squared. Remember, there's 2 possible solutions. So x minus 1 could also equal negative 3. So x minus 1 either equals positive 3 or negative 3, because that's the 2 numbers that we can square and get 9. 9 was the number that we're trying to get to. So add 1 to each side. X equals 4. Over here, add 1 to each side. X equals negative 3 plus 1 is negative 2. That's our 2 solutions. Completing the square, x equals 4 or negative 2. Either one of those substituted into there will make that true. Let's look at the 4. 4 minus 3 is 1. 4 plus 1 is 5. What's 1 times 5? It's 5. So that is a solution. It works. You can do the same thing with the negative 2. Negative 2 minus 3 is a negative 5. Negative 2 plus 1 is negative 1. What's negative 5 times negative 1? It's positive 5. So both of these are solutions, and we double checked by substituting them back in. Let's look at this one down here. This looks just a little bit different than the one above. It's a little backwards for one thing. It's got the numbers first and the x's, but it still works the same. Let's distribute the 7. 7 times 3 is 21. 7 times negative x is negative 7x. Negative x times 3 is negative 3x. Negative x times negative x is a positive. Negative times negative. Plus 3 equals 0. All right. We can combine like terms, and let's rearrange it. We can, since they're being added and subtracted, things added and subtracted could go, we can change the order. We can move the x squared to the front. It's a positive x squared. This is negative 7x minus 3x. So negative 7 minus 3 more, negative 10x. And we've got a 21 and a plus 3, so plus 24 equals 0. Okay, so what is the number that would work here? Negative 10. We cut that in half. It'd be negative 5 plus negative 5, right? And then when we take negative 5 times negative 5, It should be a 25, not a 24. So we have two choices here, actually, because you'll see this done both ways. We can move it over just like we did up here. We can say that 3, move it over so we can put the proper number there, or let's just add one more to it. Then it would be the 25 that we need it to be, but we got to do it the same to the other side. So x squared minus 10x plus 25 now is a perfect square trinomial. Now look what happens if we just subtracted it. If we subtracted 24 and moved it over here, this would have went away, and this would be negative 24. And then we would add 25 to both sides, because that's the number we needed for a perfect trinomial. Well, what is negative 24 plus 25? It's 1. We still end up with the same thing, plus 25 and 1. So either way, I'm showing you both methods here that you can use, whichever one you're more comfortable with. So this we said is the same as x minus 5 squared equals 1. Well, 1 is the same thing as what times itself would be 1, either 1 or negative 1. So our solutions will be x minus 5 equals 1, or x minus 5 equals negative 1. Okay, the first 5 is pretty bold and wild there. So add 5 to both sides on both equations. All right, so x equals 1 plus 5. X equals negative 1 plus 5. There's our two solutions. All right, not bad. Let's move on. We're doing good on time. Okay, spot those errors. Oh, I love these. Oh, wait, we got one up here. Let's do the are you ready for more. We've got two different equations, and we want to show they're equivalent to each other. So this is what we're going to do with that. We are going to, we have the x squared plus 10x plus 9 on one side, and the other one we have, this is a different form of a quadratic. This is actually the vertex form. We haven't used it very much, but this is a vertex form in some fashion, but we have this plus 4x. So it's not exactly, but it's a different form. Let's see if we can take this one and simplify it like this. Since this has parentheses, if we get rid of the parentheses, distribute and combine like terms, let's see if it equals the same as this. And that will show they're equivalent, right? So x plus 3 squared. Remember, that's the same thing as x plus 3 times x plus 3 plus 4x equals 0. All right, same thing. Now remember, if we want to, this would be a perfect square trinomial, because this is the same factor multiplied by itself. So since that's a 3, we know that would turn into x squared plus 6x. Right? That middle term is going to be the 3 doubled. It'd be a 6x. And then the last one is going to be 3 times 3. Perfect square trinomial from these factors, the x plus 3 times x plus 3, which we show right there. And we still have this 4x equals 0. Like terms, right? We've got two x terms. So that would be x squared. 6x plus 4x would be 10x plus 9 equals 0. Hey, perfect. That's exactly what we wanted it to be. X squared plus 10x plus 9 equals 0. They are equivalent. We're good. So, all right, spot these errors. Spot these errors. All right, tell you what, before we get to this problem, on our assignment today, there's going to be just an extra blank at the bottom. No question, just a blank. And that's going to be a chance to get a bonus point for anything you missed. I'll go back and add a bonus point. All right? And all you have to put in that box is Mr. Brock. Put Mr. Brock in that box. There will be no question. There will be no explanation. So if you're not watching this video, you're not going to get that bonus point. All right? So there's a chance to just get an extra point by putting Mr. Brock in there. Don't forget that. All right, let's get to this last one. Spot these errors. Here are 4 equations followed by worked solutions. So here is a solution that has been worked out. Now, let me tell you, each solution, let's highlight that. Each solution has at least one error. So these are not correct solutions. We're going to find and describe the error or the errors in each solution. So we have 2 different solutions here, and let's look at them, what they did. So we had this problem, x squared plus 14x equals negative 24. Let's see how we try to solve this. So here's the problem. So I said, all right, I'm going to make this a perfect square trinomial, right? So I cut the 14 in half. I made it a plus 28. Okay? So I took the 14, got a 7, 7 become a 28, and it equals 4. And then I said, oh, I know that 14 was a 7, so that's x squared plus 7 squared equals 4. 4 is the same thing as 2 squared or negative 2 squared, right? So it's either going to be 2 or negative 2. So I said x plus 7 equals 2. Subtract 7 from both sides, it's negative 5. Or x plus 7 equals negative 2. Subtract 7, it's negative 9. Did you spot the error? Oh, there was an error in there. I went through it like there wasn't, but let's go back and see where it is. If you take this 14x and we cut it in half, that would be 7, right? 7x. So plus 7. We know that plus 7 is correct. But how do you get this last term? You take the 7 times 7. 7 times 7 is not 28. Not 28. They did add the 28 to both sides. It would negative 24 became 4. You do have to add that number to both sides, but 28 is not the number. What is 7 times 7? This should have been plus 49. We should have added 49. So negative 24 plus 49. This should have been a 25. Should have been a 25, not that. So shouldn't have been a 2 and negative 2. It should have been what? Should have been a 5 or a negative 5, because that would be the square roots of 25. That's the two numbers that we can multiply and make 25. So x plus 7 equals 5. So this would be negative 2, because negative 2 plus 7 does equal 5. Or negative 5. What plus 7 equals negative 5? Subtract 7. X equals negative 12. So either x equals negative 2 or x equals negative 12. Those are proper solutions. Made a mistake in completing the square. Don't know where they came up with the 28. They just multiplied 7 times 4, which doesn't work. All right, let's look at this one. Hope you caught that. X squared minus 10x plus 16 equals 0. Let's see what we do here. All right, so they took the equation and they said, okay, negative 10, how does that, when you complete the square? That would be minus 5 would be half of that, and then minus 5 times minus 5 would be a plus 25. So here's what they did. They said, I had plus 16, so I just added 9 more to make that plus 25, and I added 9 to the other side. Okay, so I added to both sides. So then they said, this now being a perfect square trinomial, the roots would be x minus 5 times x minus 5. X minus 5 squared equals 9. So either x minus 5 equals 9 or x minus 5 equals negative 9. And so add 5. 9 plus 5 is 14. Add 5 to both sides. Negative 9 plus 5 is negative 4. So the solutions are 14 and negative 4. But they're not, right? There is at least one error in there. Did you spot it? Take a look at that. Do you see the error? Okay, this actually is correct. Remember, we did that on the other side. On the other problem, if we had 16 and we need it to be a 25, we can't just add 9 to both sides. That's legal. That's the second way that I showed you to work the problem. So that's okay. This breaks down. This would be x minus 5 squared. That's okay. The 9 came down. But here's where the problem was, right? It's not going to equal 9 or negative 9. That's wrong. What's that supposed to be? It's supposed to be the numbers that would multiply together to be 9. And that's not 9 and negative 9. It's 3 and negative 3. Remember, because this is the same as 3 squared or negative 3 squared. All right, that's the numbers, because we're taking just the square root, x minus 5 squared, so we're taking the square root here, and it's either 3 or negative 3. It's not the 9. Don't bring the 9 straight down, 3 or negative 3. So when we add 5 to 3, it should be 8, or if we add 5 to negative 3, 2. That should be the two solutions. All right, so that's not too bad. Let me show you. Let's see, do I have your assignment? I do not have your assignment today. It is still in there on the computer. I haven't finished that, so we'll get that. We'll get that posted, and it'll be ready. But it's the same type of problems. You're completing the square. You're looking at that and taking that middle term, take that x term, cut it in half, multiply it by itself to get the third term, And then, of course, whatever it is when it's cut in half, that's going to be your x plus or x minus. X plus 7, x minus 5, whatever that number is when you cut that in half. So completing square is not too bad, just more practice, and we'll get better at it. Otherwise, this is our last lesson for the week. Friday is tutoring day. So Friday, I'm online many hours. Look on Google Classroom, see what hours I'm there. Come on, talk to me. See what you're struggling with and bring it to, if it's one of the problems from the formative, I can pull it up on the screen. We can go through that. We can explain that. I want you to understand this because we are going to have tests. We're online the rest of the semester. If we don't have any tests, then the only grade you have for tests is what we took in the classroom. And for some of you folks, that's not going to be good. We need some better test grades to raise that up. And here's that opportunity to do that because we are going to have some online tests coming up. So that's it for today. We will see you next time, and do work you can be proud of.